Alrighty, we're going to talk about derivatives of trigonometric functions. Okay, so this Professor Dave link is also useful. So with your graphing calculator, graph sine x. So if you click y equals sine x and graph it, it looks just like this, right? And we learned this in an earlier chapter. There's our sine wave, there's our cosine wave. So they wanted you to fill out this table. This is from the textbook. And so to get these values that I'm pointing at here, what you do here, so we want to find out the value at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So using the derivative function here. So all you have to do is you've typed in your equation, and then I'm going to hit, so I got y equals sine x. Now I'm going to hit second trace, and then I'm going to go down here to dy dx, and I hit enter. And if I wanted to find out the value at pi over 4, I'm going to type in pi divided by 4. And then this is the derivative at 0.707. Or sorry, 0.707 is the derivative at pi over 4. So let me do that again. So second trace, I'm going to go down to number 6 where it says dy dx, hit enter, and now I'm going to find it at pi over 2, so I type in pi divided by 2, enter, and now it tells me that the derivative here is at 0. Okay. Now remember, notice how it's flat, or right at the maximum. The slope at the maximum is 0. Remember, derivatives tells us slope. Okay, and then we end up getting our curves look like this. So before I just talk about this, I want to talk about our Desmos activity that we just did a minute ago. So we had this screen here, and what we did was we adjusted these little dots here. Okay. So when I adjusted these little dots here, in order to get them to have the slope match, the dots had to go into these locations. So when the dots were in these locations, our slope of our original function became this. So this graph right here that's in purple represents our derivative. Okay. And this original graph, I don't know what color, I guess I'll use red. Okay, so this original graph here, this original graph is sine x. Okay? So looking at this graph here, if it starts off on the top and ends up back like this, it would go like that, right? So we discovered that the derivative of sine x is going to give us cosine x. Okay, and then from this, so here's a cosine graph, and if I move those little dots so that to make the slope match our, so like I said, these dots, when they were moved to these locations, the slope, these dots represent the slope at these parts of the line. So for example, at pi, the slope is 0. So since the slope is 0, I'm going to be hitting the x-axis at pi. Since here the slope is 0, that means I'm hitting the x-axis here at the origin, and so on. So this line right here in purple, this purple line that I just drew, represents the derivative. The derivative. This line right here represents the cosine. Okay. Now, it's hard to see with this thing. I should have made the paper go over more. But anyways, if it went up and then down, you can see, if I cover my hand over this, this is a sine wave, except it's upside down. So because it's upside down, it's reflected on the x-axis. So that means our derivative of cosine graph is negative sine x. Okay? So those are the two important things we need to remember, is to come away with from this activity, is that the derivative of sine is cosine and the derivative of cosine is negative sine. Okay, and then question number 5, we figure out how to do cosine x. Okay. So it's okay if you didn't spend that much time on this here. Basically, the Desmos activity takes care of this investigation. So, so we just said that the derivative of sine x, we've realized, is cosine x, and the derivative of cosine x is negative sine x. Question 4 isn't really that important, but the thing is, if I had my window max at 360, and if I change my mode to degrees and hit enter, and then I hit y equals, and then I've got sine x, and I want to find out when what the derivative is when x equals 0. So I hit second trace. I'm going to go down to 6, enter, and there's my sine wave. And if I hit 0, enter, it tells me that the derivative is 0.175, which is not correct, because we know it's the derivative when x is 0, for the sine wave, when x is 0, the slope is supposed to be, well, that's not correct. Okay. Anyways, what we realized is the scale on the x-axis has changed, so the slope of the tangents are going to be different. Okay. So the calculator wants you to do it in radians. That's the important thing. Okay. So question number 5, they want you to use the quotient rule to show that the derivative of tangent x is this. So if I'm using the quotient rule, I'm going to make u equal to sine x, and the derivative of u is cosine x. And I'm going to make cosine x equal to v, and the derivative of v is sine x. And we might want to remember this formula, that using our formula handout, if I can get it from my binder over here. Okay, so using the quotient rule, we're going to use this formula here, and I've just rewritten it here. So we've got v, which is cosine x, and the derivative of u, which is cosine x, minus u, which is sine x, times the derivative of v, which is negative sine x, divided by v squared. Okay, now I can write cosine squared x, cosine x as cosine squared x, negative minus sine x times negative sine x is going to give me positive sine x squared, and they have a trig identity that cosine squared x plus sine squared x is 1, and now I've just proved that tangent x is equal to 1 over cosine squared x. So, you might want to hit pause. These are the formulas that you need to remember. Is the derivative of sine x is cosine x, the derivative of cosine x is negative sine x, and the derivative of tangent x is 1 over cosine squared x. And we'll be using these today. Okay, now in this example here, they wanted you to use chain rule of y equals sine 2x. So if I'm going to use the chain rule, I'm going to say, okay, I'm just going to call this stuff in blue u. Okay, so that's u. Okay, and so sine of u, the derivative of sine is cosine, so the derivative of sine u is cosine u. Okay, and the derivative of u is 2. And so from the chain rule, you should remember dy dx is equal to dy du times du dx. So dy du is cosine u, and du dx is 2. And then I replace u with 2x, and we get this. Similarly, we do the same thing with chain rule. And once we do this, we should recognize this hint that they've just... So if I've got y equals sine ax, the derivative of that is going to be a cosine ax. And if I've got y equals cosine ax, the derivative of that is going to be negative a sine ax. So what we just did was we demonstrated this hint. Maybe you want to write it down like I just did. But this relationship is something that you can simply use. It's not written in the formula sheet, but if you don't remember that the derivative of sine ax is a cosine x with the a out here, you can simply use the chain rule to derive it, but you don't need to do it that way. Okay, so I'll do a couple more of these. So we're going to have to use quotient rule. I'm going to make u equal to cosine x, and the derivative of that is negative sine x. I'm going to make v equal to x squared. So the derivative of x squared is 2x. Okay, so once again, for a quotient rule, it's v times the derivative of u. I'm just going to rewrite this here. V times the derivative of u minus u times the derivative of v divided by v squared, right? That's what we have here. So I've got v times the derivative of u minus u times the derivative of v divided by v squared. Okay, and then we multiply this through, multiply that through, that's over x squared, and then I notice, there's x squared here, there's an x in this term. I could factor out an x and simplify this. Okay, I'll explain a few more of these, and then you can just look at the key and check your answers. The derivative of 4 sine x is 4 cosine x. Okay. Okay, this is using that relationship that we just did on the previous page on example 15, where the derivative of cosine 4t would be 4 times negative sine 4t. If you want to see this with the chain rule, I've got the steps here. Okay. The derivative of sine 5x is 5 cosine x. The derivative of 4x cubed is 12x squared. Okay, next page. Okay, so on these we have to use product rule and quotient rule to help us out. So I've got u and derivative of u. I've got v and the derivative of v. Okay. Here I've got the quotient rule. I've got sine t, the derivative of sine t. I've got v is equal to t, and the derivative of v. Oops, shoot. Didn't mean to highlight that like that. Okay. Okay. So this assignment wasn't really much to it. It's just a lot of practicing, more practicing of product rule and quotient rule. Okay, so here's quotient rule. So we've got v times the derivative of u minus u times the derivative of v divided by v squared. And this is an interesting one because I've got negative sine squared x here and negative cosine squared x here. I could factor out a negative 1, and then I got sine squared x plus cosine squared x. And then I can this is an identity. I could replace that with 1. Okay, that was a nice one. Okay. Oh, last page. Okay. I had to use chain rule here. So I said I'm going to make x squared equal to u, where u is equal to x squared. So the derivative of sine u is cosine u. The derivative of x squared is 2x. So dy dx is equal to dy du times du dx So dy du times du dx, that's the chain rule. And then I replace u with x squared. Okay, I'm going to move this up. And I hope you find this useful, and I hope I didn't make any mistakes.